My talk, aptly programmed on a Friday, thanks for the organization for that, is I deploy on a Friday. And maybe you should too. And I'll, at the end, hopefully you'll find out why maybe you should too as well. Let's get going. A little bit about myself. I am Michiel. I'm a Dutch developer, consultant, trainer, and a speaker. I work for a company called 4Scouts. We do a whole bunch of large-scale renovation projects on legacy code bases mostly. And we deploy on Fridays, a lot. If you want to reach out to me during the talk or after to shout at me why I'm wrong about certain things or view the slides, I will post them there. That's my Twitter handle. And if at any point you have questions, please save them for after the talk. Okay, let's get going. This talk is all about deployments or deploying, and it's all about Friday. It is a Friday. And when I talk about deploying on a Friday, people usually react like this. Deploying, okay, we're deploying, that's hard enough. But on a Friday, are you completely out of your mind? Because if we deploy on a Friday, our production system goes down, right? And people go insane, and there's the business that doesn't want us to do this, and it's just, can we deploy on a Friday? Just don't. But why, as an industry, do we keep repeating this mantra? And we've been doing this for years and years and years. I'll talk about a few of the observations that I made. That's not a complete list, and I have some bias, of course, as everybody does. But one of the most important aspects of not deploying on Friday is risk, or perceived risk. And the funny thing about risk is that companies that are very risk averse, and the more you go towards government or military, for example, the more risk adverse those companies or those organizations become. And the interesting part is that the more risk adverse the company is, the less they actually deploy. And coincidentally, each deploy becomes riskier as a result, rather than less risky. Right? It's the notion that if we plan everything in advance and we think of all the things, then nothing will go wrong, right? So risk. But when you translate risk to a Friday, to deploying on a Friday, it's we don't want to run the risk that we have to work on the weekend. That whatever we do on the Friday completely screws with our weekend plans, completely screws with our Friday night plans. We don't want to run that risk, even though we may not be able to define what the risk is we are running. Right? It's not a risk we are consciously taking or not taking. Another aspect is control. And when you talk about control, you can think of the business and your client. A client may, some companies may have clients that specifically forbid them from releasing on certain days of the week, or even certain times or certain time slots in a day. It's all about control. And during the course of this talk, I'll show you how you can still keep that client in control, but still deploy to your heart's content on a Friday, on a Thursday, heck, even on a Sunday, if you so want to. Another aspect is confidence. Very much associated with risk in this context. If we say, I don't want to deploy on a Friday because I think my weekend is going to go to shambles, what we're basically saying is we're not confident in our system, we're not confident in our tools, we're not confident in our process, possibly we're not confident in our team, and possibly not confident in ourselves either. So it's all about confidence. If you have confidence in your organization, your tools, your processes, then why would a deployment on a Friday be any different from a deployment on a Monday? Confidence. Next step then is trust. So if we're not confident in our teammates, in ourselves, then that could also be a lack of trust. I don't trust your code change to be any good. I don't trust you to produce stuff that is good enough so that it doesn't screw up my weekend. I don't trust my team enough that they can build something which is good enough so that I still have my weekend plans and I have a reasonable chance of success when it comes to my weekend plans. Time to repair is also a very important part of why people say you shouldn't deploy on a Friday. If a deployment screws up and it takes 48 hours to fix it, then yes, maybe deploying on a Friday is not a good idea. But then you definitely need to look at why it takes 48 hours to fix something. And over the course of the talk, I'll show a few ways of maybe shortening that. Time to repair and time to recover. They go hand in hand. What I've also seen is that people don't deploy on Fridays, or heck, even on Thursdays, because that's almost Friday, right? On-call stress. Especially with smaller teams, and with a system where there's lots of firefighting and people spend a large amount of their time fixing bugs and fixing production issues, they have a little bit of stress. They frequently run into overtime, already fixing stuff on Tuesday night, on Wednesday night. And so they absolutely positively want to avoid what they know is going to occur, namely the Friday night overtime or the Saturday overtime. And they cannot spend time with their kids or with their family. So overtime, on-call stress, and those are basically indicative of a system which is in need of serious improvement. Now, these are just a few of the facets that I think are causing this statement. Don't deploy on a Friday. And the funny thing is, I used to say this. And it's not even that long ago. It's maybe only 5 or 6 years ago that I was very much convinced that people should not deploy on a Friday. Because I like my weekends just as anybody else, right? I'm not a masochist. If I can avoid it, I don't want to work on the weekend. Or in the evening, if I can avoid it. But let's say if I encounter a bug on a Friday, a serious bug, which is affecting a lot of consumers. Should I wait until Monday? What if the bug occurs at 3 p.m. on a Friday? What if it occurs on Thursday? If the bug is triggering something, triggering a serious production problem, if you trigger it on a Thursday, chances are you are still working it late on Friday, right? So all these things to me are indicative of something that needs improvement, serious improvement. And one of the, well, I just said I'm not a masochist, but one of the mantras I like a lot is, if it hurts, do it more often. What was that?
It sounds suspiciously like a masochist.
Yes, it does. It does. If it hurts, do it more often and learn from it. Rather than do it less often and trying to avoid risk by doing all this mitigation and planning and all those things, simply do it more often and learn and improve. And we need to do that because Friday is 20% of our working week. That's a serious amount of value you are not creating or not delivering when you actively avoid deploying usable functionality on a Friday. Now, how we get there is small steps, and that's how we get anywhere. Anyway, small steps. Big steps, you run the risk of failure. Small steps, you continuously improve, and you do it in small incremental steps. One of the key parts about improving your deployment process is automation, and I cannot say this enough. Automation is the very backbone of any continuous delivery, continuous deployment setup, any system that is flexible enough, yet automated enough to deliver and to work in a way that is consistent and predictable. If you give 10 people 10 tasks to do, and you give them the same 10 people, the same 10 tasks, the next day, already you start seeing variations in how those tasks are executed, right? Because of how people feel. They did not get a good night's sleep. They may have had a little bit too much to drink, have trouble at home. All those factors influence our performance, but they don't influence the performance of a script. So automation, automate yourself out of a job. Keep that mantra in the back of your mind. That's very key here. Now, I just uttered the words continuous delivery, continuous deployment, and to me they are part of this whole group of continuouses. We do everything continuously. Rather than thinking in terms of projects, we're thinking in terms of continuous life cycle, so products. Every day we improve. Every day is a little bit better than the day before. We not only improve on a technical level or on a functional level, but we also improve on a personal level. Continuous improvement is a very important part of the agile process, right? The team improves itself by doing frequent retrospectives and then acting upon that, and et cetera. And so we don't only improve our tools and our technology and our application, but also ourselves. Continuous everything. Now, when we deal with deployments, continuous everything to me translates into something that's relatively old, which is continuous integration, coined by Martin Fowler way, way back when. And that starts with a developer checking in some code to, say, GitHub. And when that GitHub check-in occurs, a process on the server starts, checks out the code, and runs a build. In the PHP world, we don't compile, but we can still do other things like minifying or combining, and we can do a syntax check, a lint. And then we run tests. And at the end of this whole process, we end up with one single artifact, an artifact which is tested and built, and that's where it stops. Either it works or it fails. That's continuous integration. Continuous integration also stipulates that we integrate at least daily. We integrate the changes with other developers at least daily to see where everybody is, how it merges together or not, and how it works together or not. So that we don't run into parallel courses and we never see what we do until the very end when we're ready. Now we integrate at least daily. From continuous integration, we build up to continuous delivery, where we take the artifact which is built and tested, and we automatically deploy that to acceptance. And once on acceptance, people can click and test it, and then at some point we say, okay, this is good enough. Now it can go to production. The deployment to production should be automated. The deployment to acceptance should also be automated, preferably the same script. However, and that's where the red arrow comes in, the moment the trigger to deploy to production, that's still a human effort. That's still somebody either physically clicking on a button or invoking some process somewhere, but there is still a hard human gate, right? Now, to me, the holy grail, if you will, of deployment is continuous deployment, which is where we take the human out of the equation in our pipeline. All the signals say green, and we go to production after we deployed to acceptance. That means that we need a series of checks, automated checks. Everything is automated again. A series of checks that tell us, okay, this is good enough. We are confident enough that we can automatically deploy this to production. And my personal view is that this pipeline should take roughly 10 to 15 minutes from the moment you check in the code to GitHub until the very last deployment to production. 10 to 15 minutes, because in that way, you have a very fast time to recover. If you commit something which is broken, the simple fix is revert head, deploy, and then 10 minutes later, you're back to where you were. Very fast. It also means that you have a pipeline which you can trust. If a pipeline takes 3 hours to run, if there is a build or test failure in there, you will probably not wait for the pipeline to complete, which means that you will do other work. And so work will get bundled in 1 or 2 runs of the build pipeline, and things will get muddy and things will get unclear why a test fails or why a test suddenly works again. So that pipeline needs to be very fast. Research has shown that teams that deploy more frequently are more successful. Top performing teams, on average this year, deploy 46 times more frequent than less successful teams. Last year it was even better, or even more of a change. It also means that their mean time to recover from a failure is 96 times better than less successful teams. And their change failure rate, which means that the percentage of changes or deploys, if you will, that have a failure, that have a bug, is 5 times lower for successful teams than less successful teams. This can all be found in the State of DevOps report by Puppet. And another important part of that report is that there are a bunch of factors that contribute to successful teams and how they use continuous delivery. Key part, automation, test and deployment. Integrating security into software delivery work. I think there's some talks about security today or tomorrow. Continuous integration, trunk-based development, we'll get into that. And comprehensive version control. Who doesn't use version control here? Well, I respect you for saying that. I mean that. You need to really change though, but I respect you for saying that. Let's get going. Trunk-based development. Does anybody not know what trunk-based development means? Okay. Trunk-based development, funnily enough, is a term which originated in extreme programming about 18 or 19 years ago, back when there was still a trunk. I think CVS, did it have a trunk? Somewhat. But trunk-based development basically means, in our Git jargon, only commit to master. This is usually where people start either laughing at me, stare at me with a hostile set of eyes, or just walk out of the room. Which of the three is it going to be? Laughing, no. Only committing to master. And I'll just explain why. I do think that in certain cases, especially when you are transitioning to this model, this could work. The problem with short-lived feature branches is short-lived. What is short? Is that an hour? Half a day? 1 day? 2 days? Well, there are a lot of people that say a feature branch shouldn't live no longer than a day. And the teams I've consulted with that said, okay, we're actively going to chase and possibly maim people that have feature branches alive for longer than a day, after about 2 or 3 weeks, have multiple branches that are alive for more than 1 day. The reason behind it is that a short-lived feature branch really only works if your review process is very fast and timely, and your features are very small, and you can produce them in, say, 1 or 2 hours, and then you can hand the feature branch over to somebody who's doing the reviewing, and hopefully they can immediately pull from whatever work they were doing and review that. And then you have a relatively okay chance of making it within 1 day. But only one meeting has to occur, or one task has to come in between that process, and immediately your branch starts going beyond the day limit. Which is why I tend to say no to branches. With 1 or 2 exceptions, namely work in progress at the end of the day, so that if you get run over by a bus, we can still continue your valuable work, or prototyping, which you need to share with other people than yourself. Prototypes are, of course, thrown away. They're never put in production, right? So that's fine. That's fine to put on a branch and then delete it after you've shown everybody how well your prototype worked. Now, when it comes to feature branches or any branches in general, who's ever had a merge conflict Cool. Who's ever had a serious merge conflict? It's pretty much the same group. Yes. Who's ever had a merge conflict which was merged in such a way that it obliterated about half the functionality in your code base? Yes. Well, not only in the days of CVS, but also in Git. Git resolve minus use theirs. Yes. Yes. That would do it, yes. That happened, not to me, luckily, but it happened in one of the teams I was on a few years ago. And 3 weeks later, we were still figuring out where the changes went. And people would come to us like, this used to work 4 weeks ago? Yeah. And we had to go back and basically do it all over again. Now, conflicts, we all know about conflicts. Conflicts you can view in pretty graphs, well, pretty. Or you can hear people talking about it. And this is relatively benign. Imagine the pressure you're putting the people reviewing this under, right? If you don't review this most tricky tick, then we have a merge conflict. So it's now on you. Cool. But the most important conflict is not necessarily the merge conflict, but the functional conflict, feature conflicts. So your code may merge perfectly, but on a functional level, you haven't actually tested whether that meshes together, whether that works together, right? So I tend not to do that, or I tend not to want that. Now, when it comes to branches, and I talked about code reviews or pull requests a little bit, people say, okay, Michiel, it's all nice, not using branches and stuff, but we use pull requests quite heavily to submit a pull request to our repository and then trigger somebody to do a review on that, which in itself is fine. The problem with code reviews is, like I said, if the people doing the reviewing are not timely and do not work immediately, it hinders flow almost immediately. Because you are done with your task, and then, okay, maybe you have another task to do, and then somebody starts reviewing, and they have comments. They are requesting changes to be made. So now you have to switch out of the context of your new task back to the old context again, fix it, and by that time your reviewer is working on something else. So unless you have a dedicated group of people just sitting around waiting for a pull request to come in, it's going to hinder flow. And you can optimize for that a little bit by saying that, okay, your commits need to be not larger than X, or you need not to spend time more than X time on it. Any pull request that comes in is a priority thing, so you need to drop everything you have and pick up the new pull request. But those are, to me, fixing symptoms rather than fixing the greater issue. And how can we fix the greater issue? With code reviews, pair programming. Maybe not like this, even though there's a lot of cuddling going on. It's very nice, it's very soothing, but I don't think the guy in the back can actually see what the guy in front is typing, or what he is typing, actually. But pair programming is a continuous inline code review. You wanted to take a picture of that? You're welcome. So continuous inline code review. You put two people together, and preferably those are the same two people as you would have in the pull request scenario. But now, instead of having one person doing the coding and the other person doing the reviewing in separate windows in time, you now put those two people together. And I think there was a talk about XP this morning, where the speaker also said something along the lines of production code being of significantly higher quality because of pair programming. People that are opposed to pair programming say to me, like, but I'm losing 50% of my developer capacity when we do pair programming. Forgetting the fact that you are also using those people for reviews. So it's not a matter of losing or gaining time. It's a matter of being more effective, not more efficient, more effective. You put the people together and out comes, hopefully, better quality code. You have two sets of eyes looking at the same thing. You have knowledge transfer. You can have experience levels slightly mixing and matching, so you can train a meteor by a senior or maybe even a junior and help them along, and then at some point give them the keyboard. And you can also transfer knowledge about technology that way. Somebody learned about Elasticsearch or CouchDB. The rest of the team doesn't know it. Pair program or even mob program, which is basically pair programming but then mafia style. So that's code reviewing out of the way. Now, I talked about feature branches, and people use feature branches to separate their functionality in time. Like, we want to release feature A on time X, and the releasing to us is merging it to the main line and then deploying. And we can only merge when it's done. And of course, when the feature branch is done, we never ever have to get back to it, right? Something is done, and that means it's done. The alternative to me is feature toggle. And the feature toggle allows us to decouple a deployment, which is technical. And I personally believe that a team should always be able to deploy, regardless of what the world around them is saying or screaming. They should always be able to deploy. But releasing, which is making functionality available to an end user, that's a business decision, or potentially a business decision. But deployment, those are very much a team thing, a technical thing. With a feature toggle, you can do that. A feature toggle allows you to, it's essentially a glorified if statement. And if the if statement is, if the condition evaluates to false, then that code is dormant. It's still in production, and we can still and should test it, but it is dormant until we make sure that the condition evaluates to true, and then, hey presto, things start working. And we can also use this for larger features, which we cannot finish in 1 day, or 2 days, or 3 days, or maybe even the consumer is not allowed to see just yet, but we can hide that behind a feature toggle and still do our work and still do our test-driven development and all those things and do 50 deployments per day on that simple thing because we are doing small commits. And then at the end, when we're done, when it's approved, we flip the feature toggle. This is from an actual project I was on where we had a search page on the left, an old one, and we made a new one. The one on the left was fed by Solar and MySQL and a bunch of other technologies in a legacy stack. The one on the right, a couple of microservices, Elasticsearch, MongoDB, and a few other things. You don't do that in a day. You don't do that in a week. We spent about 2 months on that. So at some point, we started making the feature toggle available for people in the network, in the company network. And they could see and view where we were going. And then we've enabled the feature toggle when we were far enough for about 10% of live traffic. And we started looking at metrics. And then we saw the metrics were okay, or at least not worse than the previous metrics. And then we started increasing the traffic. The end result, that page performed significantly better than the old page. Not only in page load times, but also in how many people were on the site, SEO ranking, all those things. This is just an example of what a feature toggle could look like. This is the candidate library. It's over on GitHub. And it's basically, you ask a manager, like, is this feature toggle now active? Yes or no? If it's active, I display whatever is behind the toggle. And I can decide active or not active based on a whole host of parameters. Is this an admin user, or is this somebody from the internal network? Does he have a special cookie set? Yes or no? All those things we can do. Right. Quickly, dealing with legacy. I'll show a few patterns that you can apply on legacy applications so that you can, essentially deploy those on Friday. Expand contract, very quickly. We have 3 clients talking to an existing API, and we want to change that API. We're adding a new API instead of changing the existing API. So we add something that's called the expand phase. We add completely new functionality, and we keep all the existing APIs, we keep them for backwards compatibility. And then one by one, we start transferring the clients until everybody's on the new API, at which point we're now in the contract phase. We can get rid of the old API. My favorite pattern is the strangulation pattern, or the strangler pattern, which sounds a little morbid, and it actually is a little bit, because if we start with a monolithic application with a database, and we have the internet connecting to it and sending all that traffic to it, that's fine. But then we start adding a proxy in between the internet and the monolithic application. Initially, the proxy doesn't do anything, just passes the traffic. And then we start adding a service with a little bit of functionality, and we add a rule in the proxy for this page, send the traffic to the new service, and let that service handle that new page. And then we add more services and more services with their own database and own storage, and we add those to the proxy. At some point, we have built all the functionality we need in our services rather than in a monolith. We can switch the monolith off. We have strangled the monolith. Branching by abstraction then, it doesn't have anything to do with Git branches or SVN branches. What it basically means that we have a client calling some legacy code in our system which is hard to test or impossible to test. We add an abstraction layer in between the clients and the module. Simply an interface. We can then test that interface, and we can change all the clients to use that abstraction layer. And then we start writing a new module, and it connects to the exact same abstraction layer. So for the clients, nothing is changing at this point anymore. They are talking to an abstraction layer, they just don't know what's behind it, or what's implementing the abstraction layer. We can completely TDD the hell out of this, and out of the abstraction layer, and at some point, we're only calling the new module through the abstraction layer, and then we can tear the whole thing apart. So those are a few patterns that you can use when you're dealing with a large monolithic application, which is hard to bring under test and hard to get confidence on. Right, continuous testing, also one of the continuouses. Continuous testing, to me, is a series of layers, essentially. We have unit tests, PHP unit, usually, where we mock the world around our classes and make sure that the unit tests are as fast as we can possibly get them, because we're going to have a lot of them. And then the next layer could be integration tests, where we may deal with an actual database and fixture data, which we have under control, so that we can decide what to do and what to look for, what to expect. Acceptance tests, BHAT or PHP spec. We can write scenarios, especially with BHAT, scenarios in clear, plain English language, which we translate into testing code. And then last but not least, we have potentially UI tests like Cypress or Selenium, which are, by their very nature, more slower, more fragile, harder to maintain, so we have a little bit less of them. That translates into something I call the continuous testing pyramid, where at the bottom we have the fastest and cheapest tests, which are unit tests, and at the top, UI tests are the slowest and the most expensive. So cost goes up as you go up, and speed goes down, or goes up as you go down. And the two clouds are very important there, monitoring and exploratory testing. Monitoring, because no test suite can catch everything. And exploratory testing, because you have to, as a QA person especially, work through your application from time to time to visit the critical paths of the code and see okay, we missed this in that test, or we missed this in the monitoring, and we need to adjust that. But good enough is good enough. Remember that I talked about the pipeline speed, but also no test suite detects everything. Nothing is ever 100% watertight. So you need to be very careful and very balanced about what you test and what you leave to monitoring, or leave to a beta test program, or leave to usability feedback or something like that. Because the pipeline speed is key. If you test everything that you have, at some point your pipeline speed will go down, your pipeline runtimes will go through the roof. Okay, closing off with a few potential ways of deploying code. Now there's a whole bunch of ways of deploying code, but I'll discuss a few patterns with you that can help you gain confidence in deployments. One of the most popular is the canary release, named after the canaries that used to accompany miners into a coal mine, and the canary would die and then people would run out of the coal mine because that was their signal that there were poisonous gases in the coal mine. Now, translating that to deployments is we have something that's going to hopefully warn us that our new version is broken. Let's say we have version 1.0 of a service in production running at 100% of the traffic. We then add the canary, which is our new service, our new version of the service, and we give it 1% of the traffic, or at least enough to make a judgment call of whether this is good enough. We then check error rates, logs, metrics, whatever you need to verify that the service is working correctly. And then we start ramping up the traffic and see if that premise still holds. And if it does, then at some point, the canary is now at 100%. At this point, it's not a canary anymore, of course. And when our old service has 0% of the traffic, and we can remove it. Blue-green deployments is essentially a canary in the sense that we try something, but blue-green is basically we have a complete set of machines or instances of containers of version old and version new. We deploy all the replicas we need, and then we flip the traffic essentially from one to the next. You can see that as having two data centers with the exact same setup, the exact same install, the exact same code, and then we flip traffic. You can, of course, ramp that up as well, instead of going from 0 to 100 in a millisecond, and then you have an idea of how it's doing. And then when we have the old set at 0%, we can remove it again. And the last one is the rolling update, where we switch every replica of the old version to a new version one by one, until we have replaced every instance of our old application with the new version. And if anything were to go wrong, it's usually with the first install or the first deploy, and we can either roll it back or we can leave it as is and fix it. Rolling updates. Okay, in a build pipeline, that could look a little something like this. This is Jenkins pipeline as code. Relatively new in Jenkins, where we define stages, sequential stages, where we invoke commands. We run tests in the first stage, and then we build a Docker image, and then we deploy that to staging in production. The stages are sequential, which means that if one of the stages fails, then the subsequent stages are not invoked. The build is read, and hopefully we hear about that. We can see that in the monitoring in Jenkins. Right now, everything is green, but if one of the stages were to fail, it would color red, and all the subsequent stages as well, and our build has failed. When the build fails, we want to know about it. Have a siren of shame, or have something on Slack, or have somebody running through the building, our build is broken. Because if you do it this way, then your build pipeline is your lifeline, right? That's what you should use to change. We don't do manual deploys anymore, so if your build pipeline breaks, then you best fix it quickly. Just to let you guys know that I'm not just preaching This was this morning. It's not actually 8:11 because that's in Greenwich time. This was during the keynote, I think. Right after, 10:10. I deploy on Fridays. This is my proof. And hopefully you can do too. If you want to have help deploying on Fridays or getting there at any point, please contact us. We have a consulting group to help you with continuous delivery, continuous deployment, all sorts of testing, reconfiguring, renovation, all sorts of things. If you want to talk about that, please come find me. We'll exchange contact details. Does anybody have a question? Yes, sir.
All the deployment methods you showed, like Canary and these things, one of the hardest things to get my head around is what to do with database changes.
Please come to my talk tomorrow morning, and I'm not joking. 9:45 in this room, as a matter of fact, database migrations without downtime. And I will enlighten you to that very process. Yes.
Let's say my feature is running like half a year in production. Do you actually remove the toggle, or do you just say?
As soon as everybody gets, let me repeat the question. If the feature is in production for a half a year, do you remove the feature toggle? The answer is yes, but preferably before the half a year starts. The important thing with feature toggles is that you need to have a cap on it. If you have 100 feature toggles running, that's impossible to maintain. So the moment that a feature goes into production and is used by all your traffic, by everybody essentially, you need to remove the feature toggle and all the if statements and all the other things. And then you are in the position, you are ready essentially for another feature toggle. Which also means that if the feature is not going into production or we're going to retract it, then the feature toggle and the code associated with it needs to be removed because that's at that point dead. Does that answer your question? Cool. Anybody else?
Do you ever run into features depending on other features? Like nested feature toggles, basically?
Yes, at some point we did, but that in itself is a moment to stop and think about it and probably refactor a little bit, because that's, or then put both features behind the same toggle, because it's probably they're the same feature then, if that's. Okay, any other questions? Okay, once again, my Twitter handle, my email address, my blog where I blog about these things, but also other stuff. And please leave some feedback on Join In, helps us to improve. Thank you so much.